going to take another look at trig equations, but this time with radians. Essentially it's the same sort of thing, but now you'll notice the range of answers we're looking for, instead of being between 0 and 360, they say, oh well, between 0 and 2 pi. So this is where you've got to be very careful. They will tell you what angle measure they want the answers in, and you've got to match it. So if I was to answer this question and put my answer in degrees, then my answer would be wrong, because they're asking for answer in radians. So let's do it. 2 sine x is minus root 3, which, rearranging it, it's one of our exact values. We're in the third and the fourth quadrant. The acute angle, now I'll admit, when I look at these, I still think degrees. So I'll see sine root 3 on 2, oh that's 60 degrees. But then I just convert it and go, oh well that's pi on 3. So then our answers, well for the third quadrant, which is normally 180 plus the angle, so now it's pi plus the angle. And in the fourth quadrant would be 360 minus, so now it's 2 pi minus. So we end up with 4 pi on 3 and 5 pi on 3. Tan squared equals 3. So again, the same sorts of questions, just that now we're using radians instead of degrees. So plus or minus root 3, all 4 quadrants this time. Acute angle, well again it's 60 degrees, isn't it? So pi on 3. As I was saying yesterday, we're going to see these exact values crop up a lot. So we have our 4 answers there, pi on 3, 2 pi on 3, 4 pi on 3, and 5 pi on 3. Ones that we can look at and say, hey, that's a quadratic equation. So I'll move the 2 over, multiplies together to give negative 2, adds together to give 1. Yeah, that's a nice one. So we've got cos x plus 2, cos x minus 1. 2 possibilities. Minus 2, well hang on a sec, that's not a possibility, is it? Because we know cosine goes in between minus 1 and 1. So that'll have no solutions. The other one, that's the boundary value. Cos x equals 1. So we know the boundary there was at 0 or 2 pi. One's where we have to use a trig identity. So the sec squared I can change to 1 plus tan squared. Again, make it look like a quadratic, and that one factorizes as well. This time they will both produce solutions. So tan x is negative 1/4. We're in the second and the fourth quadrant. Now 1/4 is not an exact value. So this one I'm going to have to do a decimal approximation. So when we were dealing with degrees, we normally did it to the nearest degree or the nearest minute. Well, when we're doing radians, we'll usually do it to so many decimal places. Now, they haven't told me how many, so I'm going to do 3. Usually 3 or 4, sometimes you'll see 2, but if they don't tell you, that's what you go with. And we'll take it away from pi and also 2 pi, and we have our 2 possibilities there. The other one is an exact value, tan x equals 1. The acute angle was pi on 4, 45 degrees, pi on 4. Combine them all together. My final solution for this one's going to look a bit strange, because some of them I'll have as exact and some of them I'll have as approximation, but I'll put them in order, and that's what we get. Pi on 4, 2.897, 5 pi on 4, 6.038. Oh, sine 2x. So x in this one's going between 0 and 2 pi, but we're looking for 2x. So we're looking for answers between 0 and 4 pi. Going to go around the circle twice. So first of all, we find 2x. And it's the first and the second quadrant. The acute angle for this one is pi on 4. So we have our 2 possibilities for 2x, but we're going around the circle twice. So with degrees, we would have added on 360 to each one. Well, in radians, we'll add 2 pi onto each one. So we get 9 pi on 4 and 11 pi on 4. Now we divide everything by 2, and we get our 4 possible answers. So really the same sorts of things we've seen in trig equations, but now our answers, a lot of times we can write them as exact, but if you can't write them exact, then all right, we'll round off to so many decimal places.